Good morning, students. Just after the completion of the first chapter, that is the basic concept in chemistry, now switch over to the second chapter, that is the structure of an atom. The structure of an atom, or we write atomic structure. So today, that is the first class for the chapter atomic structure. In this structure, today I try to complete the introduction about electron, proton, neutron, that is the fundamental subatomic particles. Then the first attempt made by J. Thomson. According to him, that is Thomson atomic model. Then, according to Rutherford, alpha scattering experiment. Then Rutherford atomic model and a failure of Rutherford atomic model. So before going to this, let us start with the first introduction part. What do you mean by the term atom? The word atom is derived from a Greek word which means indivisible, means not divisible. That is, it is the ultimate particle which is not further subdivided. In every chemical reaction, the reacting unit is atom. Atom is neither created nor destroyed. Atom of the similar elements, similar in shape, size, mass and characteristics. However, atoms of the different element differ in their shape, size and other characteristics. According to J. Thomson and Rutherford, an atom consists of so many particles like electrons, protons, neutrons, positrons, mesons. So many particles are there which are known as subatomic particles. However, we may focus to three subatomic particles, that is electron, proton and neutron. These are known as fundamental particles because in every cases these are always used as the fundamental particle, that is electrons, protons and neutrons. So before going to the chapter, it is necessary to know some fundamental idea about the subatomic particles, that is electrons, protons and neutrons. So first, it is better to go through, give 2 to 3 to 4 points about the subatomic particle, that is electron. For electrons. Point 1. Discovered by point 2, charge, point 3, mass, charge of an electron, mass of an electron, point 4, charge by mass ratio, point 5, charge of 1 mole of electron, point 6, mass of 1 mole of electron. So before going to this one, let us recap what is electron. Electron nothing but a subatomic particle having unit negative charge and mass is equal to 1 by 1836 of the mass of hydrogen atom. Mark that. That is, it is discovered by, first one is electron was discovered by J.J. Thomson. Mark that. Discovered by J.J. Thomson. Next, the charge of an electron is equal to 1.602 into 10 to the power minus 19 coulomb. Next, mass of an electron 9.1 into 10 to the power minus 31 kg. Next, charge by mass ratio is equal to 1.76. Charge by mass ratio 1.76 into 10 to the power 8 coulomb per gram. Then charge of 1 mole of electron is equal to 96500 coulomb or 1 Faraday. Then mass of 1 mole of electron 0.55 milligram. These are some data necessary to recall for the electron. Charge 1.6 into 10 to the power minus 19 coulomb. Mass 9.1 10 to the power minus 31 kg. Charge by mass ratio 1.76 into 10 to the power 8 coulomb per gram. Then charge of 1 mole of electron is equal to 9.69500 coulomb or equivalent to 1 Faraday. Last one is mass of 1 mole of electron nearly equal to 0.55 milligram. Next we discuss about some typical points about proton. What is a proton? It is also a subatomic particle. It is a subatomic particle having unit positive charge and mass is equal to nearly that of the mass of one atomic mass unit. Mark that. The point 1 is, it is discovered by E. Goldstein. Then charge of one proton is equal to 1.602 into 10 to the power minus 19 coulomb. Mass of a proton equivalent to 1 AMU, that is 1.672 into 10 to the power minus 24 gram. Charge by next one, charge by mass ratio is 9.58 into 10 to the power 4 coulomb per gram. Then charge of 1 mole of electron is nearly equal to 96500 coulomb or it is 1 Faraday. Mass of 1 mole of, it is a proton. It is also proton. Then mass of 1 mole of proton is nearly equal to 1.007 gram. It is the little idea. It is a little idea about the proton discovered by E. Goldstein. Charge of proton, mass of proton, charge by mass ratio proton, then charge on 1 mole of proton, mass of 1 mole of proton. Then switch over to third subatomic particle, that is neutron. That means what is a neutron? Neutron also a subatomic particle. Neutron also a subatomic particle having mass nearly equal to the mass of one atomic mass unit with chargeless, having no charge is there. So now let us consider some fundamental data relating to the neutron. Next we discuss about the neutron. Neutron is also a fundamental particle and discovered by Chadwick. Mark that, it was discovered by Chadwick. It is also a fundamental particle having mass is equivalent to that of one atomic mass unit with having no charge. So mark the point. Described by Chadwick. Charge, no charge, mass, that is 1.67 into 10 to the power minus 24 gram. Charge by mass ratio is 0. Next, charge of 1 mole of electron is 0. The mass, next, mass of 1 mole of neutron equivalent to 1.008 gram. It is the little idea about the subatomic particles, that is like electrons, protons and neutrons. So just after the discovery of electron and proton, the scientists tried to arrange the electron and proton in an atom. Among them, the first attempt made by J. Thomson, and according to him, that model was known as Thomson's atomic model. Next, we discuss about Thomson's atomic model. Mark that. Next, we discuss Thomson's atomic model. According to him, the positive charge are spread. According to him, the positive charge spread over a sphere in which electrons are embedded. Mark that. Thomson's atomic model. Thomson's atomic model. According to him, a sphere is there, positive charge are spread over the sphere, positive charge are spread over the sphere, while electrons are embedded kept in this in order to maintain the electrical neutrality. So this model, the Thomson atomic model, also compared with a watermelon in which seeds are embedded in the watermelon. So this Thomson atomic model also compared with a watermelon. However, this model could not explain satisfactorily the different experimental observation. That's why it was rejected. Next attempt given by Rutherford. So next switch over to Rutherford alpha scattering experiment. Next one is Rutherford alpha scattering experiment. Rutherford alpha scattering experiment. The scientist, that is Rutherford, and his co-worker made one experiment on thin gold foil having the thickness 0.00004 centimeter thickness, and it is known as alpha scattering experiment. He bombarded a thin sheet of gold foil with alpha particles. What is alpha particles? That is a doubly charged helium. We know helium, atomic number 2, mass number 4. It has 2 electrons. When it loses 2 electrons, that is He2 plus. This is known as alpha particle. So Rutherford bombarded alpha particles to the thin sheet of gold foil. In his experiment, he observed that mark that it is the thin sheet he observed that maximum alpha particles move straight without any deflection, while minimum make a little bit deflection, a very few make a reflection, that means making an angle of 180 degree. I repeat again, he bombarded alpha particles to a thin sheet of gold foil and observed that maximum alpha particles penetrate straight through the gold foil without any deviation. Few of them deviate, making some angle, while a very few, that means 1 out of 20,000, deviate, making an angle of 180 degree. So from this experiment, from this alpha scattering experiment, he drew the following conclusion. We discuss, that is one by one. Next we discuss about the main postulates of Rutherford atomic model. Mark that. Postulates of Rutherford atomic model. 5 to 6 points are there. We discuss, that is one by one. In an atom, the total mass is centered at its center, which is known as nucleus. I repeat again, the first point is that is in an atom, the total mass of the positive charge. In an atom, the total mass of the total mass and positive charge is concentrated. Total mass and positive charge is concentrated at the center, which is known as nucleus. Mark that, the important point. In an atom, the total mass and positive charge is gathered at the center, which is known as the nucleus. Point 2. The volume occupied by the nucleus. Point 2. The volume occupied by the nucleus is very small or negligible as compared. The volume occupied by the nucleus is very small, is or negligible as compared to the total volume of the atom, compared to the total volume of an atom. Mark that. This is the positive charge and mass of an atom, which is gathered centralized at the center of an atom, which is known as the nucleus. And if we compare the total space occupied by the nucleus with the total atom, it is very small, that can be negligible. Mark that. Next point, the third point. The mass In the center, only the positive charge nucleus means there is the presence of a proton. Point 3, the charge of the nucleus is due to the presence of a proton. Point 3, the charge of the nucleus is due to the presence of proton. The nucleus, we know that the positive charge is due to the presence of a proton. Next, the mass of the nucleus is due to point 4. The mass of the nucleus is due to the presence of protons and neutrons which are collectively known as nucleons. We know that nucleus is a positive charge, so that is the presence of a proton is there, and as the neutron is neutral, so at the center, neutron and proton that is present in the center or in the nucleus, which is known as, each constituent is known as nucleons. So the mass of the nucleus is due to the presence of proton and neutron, which are collectively known as nucleons. Next point, nucleus is surrounded by negatively charged electrons. Next point, fifth point. Fifth point, nucleus is surrounded by negatively charged electron. Mark that. Next one is nucleus is surrounded by negatively charged electron which balance the positive charge of the nucleus. That is the positive charge of the proton present in the nucleus. As a result of which an atom is electrically neutral. Mark that. We know that the nucleus is a positive charge, that is the presence of a proton and a neutron, while electrons are revolving around the nucleus, as a result of which total positive charge is cancelled out by the total negative charge. So an atom is electrically neutral. Move to the next point. Point number 6. That is, when electron revolve around the nucleus, there is a force generated that is known as a centrifugal force. The negative charge electron when revolve around the nucleus always try to away from the nucleus, that is known as centrifugal force. While the nucleus attract the electron towards itself, that is known as centripetal force. These two forces cancel out each other, as a result of which there is no chances of coming the electron towards the nucleus or fall into the nucleus. Mark the next point. The centrifugal force developed due to revolution of electron around the nucleus is cancelled by the attractive force on the revolving electron. As a result, the chances of coming of electron towards the nucleus is cancelled. That means the positive charge and the negative charge, the attractive force and the repulsive force cancel each other, as a result of which electron move around a particular path and no chances of coming near. And the last point is that the space is maximum between the nucleus and the revolving electron in an atom. Next point, last point. The space between the last point of the Rutherford atomic model, that means the space between the nucleus and the revolving electron is maximum. These are the various postulates of Rutherford atomic model. Next, we discuss about what is the drawbacks of the Rutherford atomic model. Next, we discuss about the failure of this model. Mark that, failure of Rutherford atomic model. Rutherford atomic model. There are two important points, very important, two important drawbacks of this model are there. Point one, mark that. This model, Rutherford atomic model, was compared with the solar system, model of solar system, in which nucleus is compared with that of the sun, while the revolving electron compared with that of the planet. Mark that. This model was compared with that of solar system, in which nucleus is compared with sun, while revolving electrons compared with the planets. But there is a great difference between this comparison, because electron is very small. Electron has very small masses and with negative charge, while planets are having massive one and neutral one. Mark that. But this comparison is not correct as because electron has very small mass with negative charge, while planets are massive and are neutral. So this comparison has no meaning. Next, switch over to the second point. It fails to explain the stability of an atom on the light of electromagnetic principle. Mark the second point. Next point, point 2. It fails to explain the stability of an atom, on the basis of electromagnetic principle. Mark that. The scientist Clerk Maxwell, according to the scientist Clerk Maxwell, when a charged particle revolves around the attractive forces, continuously loses energy. Since electron is also charged particle, it emits radiation and loses energy continuously, as a result of which it comes nearer to the nucleus and finally bombarded with the nucleus. We know that revolving electron never fall into the nucleus. Mark that. According to scientist Clerk Maxwell, when a charged particle revolves around unattractive forces, loses energy continuously, as an electron is also a charged particle, emit radiation and loses energy continuously, and finally fall on the nucleus. But we know that an revolving electron never falls on the nucleus. These are the two important demerits of Rutherford atomic model. So today, students, in the class 1 of the chapter atomic structure, I able to give a little idea about the subatomic particles, what is electron, proton and neutron, and some fundamental values of relating to electron, proton and neutron. Then what is Thomson's atomic model, what are the demerits of this model, what is alpha scattering experiment, what are its drawbacks, and on the basing upon the alpha scattering experiment, how Rutherford able to provide little idea about the structure of an atom and what are the drawbacks of Rutherford atomic model.